Hello everyone, my name is Panapong Chalaong. I am a master degree student at Prince of Songkhla University. My advisor name is Associate Professor Dr. Chris Somnik. Today, I would like to take this opportunity to talk to you about the research topic is free fatty acid reduction of palm oil meal effluent using heterogeneous acid catalyst for esterification. This slide highlights the content of this study. First, I would like to introduce you to why I am interested about the renewable energy, with an interesting to use the waste like the palm oil meal effluent as a feedstock for the production of renewable energy. Next, I will talk about the materials and methods, experimental results and discussions. And then I will conclude with a summary of this research on this topic. This slide will show why this research wants to study about the renewable energy. Recently, fossil fuels are the energy resources that are generated from chain remnants of living organs, such as plants and animals, that have been deposited for a long time through incineration. In this way, it will cause a global warming, which will have the wide impact and need to find the alternative energy to solve this problem. One of these interesting alternatives is a biodiesel fuel. This slide will show about the raw materials. The raw material which can use to produce the biodiesel can be found in many places, such as edible oil and non-edible oil that show in the slide. But this research will focus on the raw material based from the waste, the palm oil meal effluent from the palm oil milling process. Why this raw material is very interesting, I will ask about it in the next slide. A palm oil meal effluent that I will call POME was produced from a commercial scale palm oil milling process. POME is the wastewater from sterilization, double screw pressing, and the separated slag from crude palm oil production. The primary two significant sources of POME are separated slag and sterilizer effluent, which contribute to the highly polluting characteristics of the wastewater. POME, or the palm oil meal effluent, is often classified as a factory waste. Most factories in Thailand sell to soap factories at a cheap price. If these wastes are processed into the biodiesel that can be used as a renewable energy, it will add value to this waste as well. It also helps to reduce waste that may cause the pollution in the future as well. This slide will show the property of the POME, or the palm oil meal effluent. The palm oil meal effluent is a low-cost waste from palm oil milling process, and it will be the semi-solid phase at a room temperature of 30 degrees Celsius as shown in the figure A, and a melting point at approximately 45 degrees Celsius as shown in the figure B. This slide will focus on the esterification process. The esterification, which the process can reduce the free fatty acid by having a reaction between the free fatty acid from the raw material and the alcohol, and use a catalyst to help the reaction faster. Using the homogeneous catalyst like a sulfuric acid is popularity because it's easy to use. Normally, the sulfuric acid is widely used as a catalyst because it's easy to use and the price is cheaper than the heterogeneous catalyst. However, the sulfuric acid still need to eliminate by reducing the pH before releasing into the environment, and it's very dangerous to use. Therefore, this research topic will focus on investigation about the alternative ways to use the catalyst like a heterogeneous catalyst type AMBLI-15. The advantage of using the heterogeneous catalyst like is no need the chemical treatment process, and it have the reusability, easy to remove and non-toxic chemical. So that is the reason why this research want to study about it. Next, This slide will begin to show you about the materials and method. The first, I will start with the chemical substances. This research will use the palm oil meal effluent as a raw material. The palm oil meal effluent contains 89.16 of free fatty acid. That is the major content, and the minor content like triglyceride, diglyceride, and monoglyceride is around 11. Next, the methanol. The commercial methanol of 99.8% was used in the production of substance amylase 15. The ion exchange resin amylase 15 were used as a heterogeneous catalyst. This slide will show about the schematic diagram for free fatty acid reduction of palm oil meal effluent is shown in the figure. To prepare for the experiment, palm oil meal effluent was heated at 60 degrees Celsius to decrease its viscosity before poured into a reactor of 5 neck round bottom flask. The temperature of the reaction was regulated using a circulating warm water bath, which was monitored with a digital thermometer. To mix the reactant of the mixtures, a 6-blade turbine was employed, which was operated by a motor at a stir speed of 300 rounds per minute. For the beginning of the procedure, the methanol was gently filled into the glass bottom reactor under the following condition of 12:1 molar ratio methanol to oil, and maintained the temperature of mixtures until its temperature reached to 60 degrees Celsius. The amylase 15 catalyst was immediately added into the flask to accelerate the esterification reaction and immediately counted reaction time to begin the esterification process. At every 1 hour period, 10 ml sample for 3 repeated times were kept at a sampling port. All samples were cooled at once in cold water to end the reaction. In the next step, the solid catalyst was removed and pretreated oil was carefully washed with warm water to remove the methanol residue. The components of the free fatty acid, methyl ester, and the glyceride in pretreated oil were checked by the thin layer chromatography with flame ionization detection. This slide will show about the step of the TLC-FID analysis. The analysis of the sample content, the composition of the reaction mixture sample were determined by the thin layer chromatography equipped with flame ionization detector. The first, 1 microliter of the reaction was diluted in hexane at appropriate dilution. Step 2, it was spotted onto the coumarods. Step 3, the coumarods were immersed in the solvent mixture of TLC1 solution until the solvent reaching to 8 cm, approximately 15 minutes. Secondly, the coumarods were immersed in the solvent mixture of TLC2 solution for about 35 minutes, or until the solvent reached to 10 cm. Step 4, the coumarods were then dried at 105 Celsius degree for 5 minutes and scanned with the TLC-FID. The scanning was performed using a 160 ml per minute of hydrogen flow rate and 20 liters per minute of air flow rate to produce the chromatogram. The composition were calculated as weight percent based on the peak area of each component. Next, this slide will begin to show you about the results and discussion. This slide I will show about the results. In the left hand side, as for the experimental results on the left, it is shown in the section on the relationship between reduced free fatty acid content and the reaction time using a total of 8 hours. The volume decreased from 89.16 weight percent to 1.33 weight percent, Under the catalyst concentration of 40 weight%, reaction time 8 hours. The methanol to oil ratio at 12 to 1, 300 round per minute stellar speed, and it will reach equilibrium at 5 hours under the same condition. And in other catalysts concentrated, it may take more than 8 hours to reduce the free fatty acid content to be suitable for biodiesel production. The right-hand side shows the relationship between the methyl ester, which same as a decrease in free fatty acid in the left-hand side, begin to sharply increase at 1 hour. A catalyst concentration of 40 weight%, entering an equilibrium point at 5 hours, same as the free fatty acid conversion, and steady start the value were 82.71, 82.78, 82.81, and 82.94 weight%, respectively. Other concentrations such as 10, 20, 30 weight% has the highest purity of methyl ester at 59.98, 73.77, and 82.59 weight% respectively. The conversion of diglyceride, and monoglyceride value were not observed. No different value of the composition at 10, 20, 30, and 40 weight% of amylin-15 concentration at all reaction time. The conclusion. This slide what show about the conclusion. The first, free fatty acid reduction in palm oil meal effluent from esterification process was sharply increased by the 40 weight% amylin-15, and it reached equilibrium level at 5 hours. 2. The condition of 40 weight% of amylin-15, 5 hour reaction time, 12 to 1 methanol to oil molar ratio, 300 round per minute speed of the stellar are recommended to reduce the free fatty acid in the palm oil meal effluent from 89.16 weight% to 1.75 weight%. 3. Amylin-15 has the potential to be used as a solid acid catalyst due to its significant influence on the free fatty acid reduction in palm oil meal effluent using esterification process. Thank you for your attention.